Now students, let me start a few points regarding the refraction. See, what is the reason behind the refraction, then why it occur? Then refraction occur due to speed of light is differ in different medium. So ultimately we can say that the refraction certainly depend on the speed of light. Speed of light. Okay, it's going to be measured by refractive index. It's going to be measured by refractive index. See, the symbol of refractive index is eta. In some of the school, they use the mu. Both we can use for the refractive index. Here we use the eta. So eta, it is known as speed of light in a vacuum to speed of light in any medium. So eta is equal to C upon V. See, the speed of light in a vacuum is remain the constant. So C, it's 3 into 10 raised to 8 meter per second. Already we know that. So with the help of this, we can find out the refractive index of any object, any matter, we can find out it. Okay, this refractive index is also known as the absolute refractive index. It also known as the absolute refractive index. What do you mean by the absolute refractive index? Once we compare the speed of light with the comparison with vacuum, then it's going to be considered as the absolute refractive index. It's very interesting. Another refractive index is known as relative refractive index. Now, very interesting term, relative refractive index. When compare speed of light in two differ medium, then it going to be considered as the relative refractive index. Let's see. For example, here we can compare, we have a medium 1, it's water, and medium 2, it's glass slab. So light will move from water to glass. So here, if we can say that its refractive index is the eta 1 or eta W, its refractive index is eta 2 or eta G. So refractive index of medium 1 with respect to this, with respect to, we are going to be write down the WRT, with respect to medium 2 is eta 2 upon eta 1. Eta 2 upon eta 1. So we can write down that this one is eta 21. So eta 21 means eta 2 upon eta 1. Here, if we just going to be write down in details, then there is a eta 2. Eta 2 means what? Then C upon V2. Yes or no? Eta 1 is what? C upon V1. So here we can say that C upon V2, C upon V1, both are cancelled. So V1 upon V2, this is known as the speed of light in medium 1 upon speed of light in medium 2. So this refractive index, when we are going to be compared to medium, then it is known as the relative refractive index. Why? When we compare refractive index of any medium or speed of light in any medium with the speed of light with a air, then it's going to be considered as the absolute refractive index. So refractive index have a two types, absolute and relative. Got it? Now we have to see one more interesting thing. And it is known as law of refraction. It's a Snell's law. It's known as the Snell's law. According to the Snell's law, sin I upon sin R is equal to eta 2 upon eta 1 is equal to eta 2 1. Here I angle, it's known as the incident angle. R angle is known as the refracted angle. Eta 2 and eta 1, they both are refractive index of medium 2, refractive index of medium 1. This is the most important law for the refraction. Got it? So here we have to see in actual life how refraction it's going to be occur. Simply we can say that we have a glass of water and we just going to put a pencil. Then you just consider, you just see there is a pencil, it's going to be bent. When we observe from the upper side, we feel that pencil it's going to be bent. So this is called as the refraction phenomena. This is called as the refraction phenomena. Here, if I just maybe see like this, when we are going to be seeing in aquarium, there is a lot of fishes will be there. When we see from the upper side, like here, if we just maybe see a fish, then definitely this is water. Here fish it's like this, okay, but actually it's going to be see here. So see, there is a one called as the real depth and one is called as the apparent depth. This is called as the I and this is called as the R. And the distance between them, the distance between real depth and apparent depth is called as lateral shift. Is called as lateral shift. So this distance is known as the lateral shift. This phenomena It's going to be observed during the refraction. Thus both are fish. Okay, fine.